So now let's take a look at combined gas law. So this is when you have, so you're going to have to read your question and make sure what they're asking you. And in these particular questions, you'll notice that you'll have volume, pressure, and temperature being asked from you. So in this situation, you are going to use something called the combined gas law. So if you take all of your gas laws, Boyle's law, Charles's law, and Gay-Lussac's law, and you take a look at them, I've color-coded them for you so you can take a look. These are all subsets of this new combined gas law, which looks like this. You have PV over temperature, and so you can see here the volume and the temperature relationship with Boyle's law and Charles's law, and then the same values for Gay-Lussac's law. So if you kind of combine all of them, you're going to get this combined gas law. Now the biggest trouble students have is to substitute their values into this. Okay, so when Boyle's law, Charles's law, and Gay-Lussac's law are combined, a pattern is noticed. Pressure and volume are directly related to temperature and inversely related to each other. So it's this results in the new combined gas law. Okay, so make sure you record this formula. Again, T is measured in Kelvin. Okay. The other way that you can remember it easier for substitution is PV P1V1 T2 equals P2V2 T1. Okay. So here's an example. So this is easy because it tells you here's the combined gas law, but in the exam you're not going to get this. You're just going to get the fact that there's 150 milliliters, 260 Kelvin, 92.3 kilopascals. But looking at that, you have 5 values here. You know you need at least an equation with 6 unknowns. Okay, so you need to know you have to use the combined gas law. Okay, so let's substitute in sample of gas as 150 milliliters. It's at this 260 Kelvin. That's your temperature or your pressure, and then your pressure is 92.3 kilopascals. Make sure your units are the same. So yes, Kelvin, Kelvin, kilopascals, kilopascals. If they're not, you have to convert. Okay, so 376 Kelvin, 123 kilopascals. So I'm looking for the new volume. So I'm going to rearrange my equation. Kilopascals cancels out. Kelvin cancels out. I'm left with milliliters, so 163 milliliters. Okay. Just a revision on things that you need to know. STP is 0 degrees Celsius, 101.3 kilopascals, and SATP, ambient temperature and pressure, is 25 degrees Celsius at 100 kilopascals. This is at sea level, so really low increase in pressure. This is higher up in the atmosphere. Okay, so ambient. So that's why it is a higher temperature but a lower pressure. Absolute 0, 0 Kelvin, or minus 273 degrees Celsius. Here's Boyle's law, Charles' law, Gay-Lussac's law, and the combined gas law. All right, and again, we'll work on worksheet 5 in class tomorrow.